Okay, so let's finish this section, this chapter 6, section 1, applications of integrals. So last time we did, the first video that we did was about the area between curves, case 1. Okay, so we did case 1. So today we're going to do case 2. So for case 2 we have a different type of the region. So for case 2, the region is bounded uh, to the left or from the left by x equals g of y, and then from the right by x equals f of y, below by this time by the horizontal line y equals c, and above by the horizontal line y equals d. So basically we're talking about this region R. So again, the same question is to find the area of this region R. And here we describe the region R to be bounded from the right by x equals f of y, from the left by x equals g of y, above by y equals d, and then below by y equals c. And again, as often, the question is to find the area of this region R. So that's the question there. The answer is that for this time we're going to integrate the difference of two functions. So the function that is to the right minus the function that is to the left. So we're going to integrate right minus left, meaning we're going to integrate f of y minus g of y dy. The limit of integrations are going to be c and d. C is less than d. So c is going to be at the bottom limit of the lower limit of integration, and the d is the upper limit of integration. So then you get f of y minus g of y. You integrate from c to d. So everything here, this integral is a function of y, okay, y variable. So again, I just to make it a little bit easier, I write right minus left instead of f of y minus g of y. So we go to the problem. Find the area of the region R enclosed by the given curves. So this time they give us x equals 2y squared, and another curve is x plus y equals 1. So the first thing, the solution is that the first step, first we're going to sketch the region. To sketch the region, we have to graph x equals 2y squared. So if you graph x equals y squared, if 2 is not there, the graph will look like this. But 2 times y squared, just make this graph a little bit wider. Okay. So we can assume this is the graph of x equals 2y squared. The graph of x plus y equals 1 is just a straight line, so you can use the intercepts to graph it. If you find, first we find the x-intercept by setting y equals 0. When y is 0, x is 1. So when you plot 1, 0, it's here. When x is 0, you get y equals 1, so you have this point here. You connect the 2 points, it gives you the line, the straight line here. Now the region that is enclosed by this 2 curve is this region, shaded here. So the question here is, what is the area of this region? Notice that the limit of integrations are not given. So we'll have to find limits of integration. Okay, so we know the limits are going to be a function of y. So this is where the 2 curves are intersecting. So this point here and that point there. So that's where the curves do intersect. So we're going to find the y coordinate of this point, and then the y coordinate of this point. That will give us the limit of integration. First, before we use the formula to integrate, we'll have to write this x plus y equals 1 as a function of y. So basically we'll have to move y on the other side. So you get x equals 1 minus 1. So we can so when you're facing this region, when you're facing so you basically you're going to sit in front of your piece of paper, facing your piece of paper. Then you use your right arm, which is here. That's the right. So this curve is to the right of the region, and the bottom curve here is to the left of the region. So when you want to integrate, you're going to integrate right minus left. So you're going to integrate 1 minus y minus 2y squared. Okay. So that will be the integral. Now, what we need now is limits of integration. Limits of integration to find them is the point of intersection of these two curves. To find the point of intersection, we'll have to set these two curves to be equals. Okay. So this curve, we solve it first for x. You get x equals 1 minus y, and then the other one is x equals 2y squared. So when you set these two to be equals, we're going to set the right side to be equal. So you get 1 minus y equals 2y squared. You have the second degree equation. To solve it, anytime you're trying to solve a second degree equation, you will be advised to move everything on one side and then leave a 0 on the other side. So I decided to move these two on the other side. When you move negative y on the other side, it will become positive y. You move 1 on the other side, it becomes minus 1. So you get this equation. You can use, from here you can use quadratic formula to solve it. Or if you know how to factor, you can factor this equation as a 2y minus 1. Quantity 2y minus 1 times quantity y plus 1. And then you set this factor to 0. You solve for y, you get a half. You set it y plus 1 equals 0. You solve for y, you get negative 1. So the smaller number is always called c, and the bigger one will be called d. So those are limits of integration. So going back to the integral, we'll have to integrate from c to d, so from negative 1 to a half. What we're going to integrate is right minus left. The right function is 1 minus y, the left function is 2y squared. So you're going to have 1 minus y minus 2y squared. Removing parentheses, you get 1 minus y equals 2y squared. And then you integrate that from negative 1 to a half. So when you integrate 1, you get y. When you integrate y, you get y squared over 2. When you integrate the 2y squared, you get y 2 times y cubed over 3. So you're going to evaluate this result at negative 1 and 1 over 2. By the fundamental theorem of calculus, when you do the evaluation, you will evaluate this answer at always the top limit first. Okay. So you're going to plug in a half for y into this function. So that will give you this. And then you plug in negative 1 for y into the function. It will give you a second set of data, and then you take the difference of the two. So when you take the difference of the two, you're going to end up with 9 over 8 as your final answer. So the area of that region is 9/8. Thank you.